Hello students, and welcome to this calculus lesson. In this lesson, we're going to start learning about Riemann sums and how antiderivatives are going to relate to actual real life scenarios. So let's get started. As I was kind of saying last time, we have the antiderivative, right? The integral of f of x dx, and that's sometimes called the indefinite integral. Well, here, when we're actually bounding the values or bounding a curve from a to b, we call that the definite integral because it's actually defined. So Riemann sums give us a way to find area under a curve. In fact, they're actually used to deepen your concept of finding area between two curves, area and volume, things like that. So Riemann sums is going to be your first step, and they're used to estimate area between a curve and the x-axis. So let's look at this function over here on the left. We have negative 1/3 x squared plus 2x plus 5. We see that it is graphed over here from 1 to 7. So we do see that we want to cut this off from 1 to 7 right there. So what we want to do is we want to find a left-hand Riemann sum with intervals of length 2 units. So a left-hand Riemann sum, what you're going to do is on your graph, you're going to look from 1 to 7, and you're going to start on that left part, the left part of the interval, and you're going to draw a rectangle for 2 units. Okay, so make it flat, and then you're just going to draw it down and draw it down. Now at the next part, now that you're 2 units over, now we're at 3, you're going to go up to the next value of where the function is, and that is where you're going to draw for 2 units a rectangle. And the same thing again, wherever, so now we're at 5, you're going to draw it on the left hand, so we're going for 5 here. You're going to draw it for 2 units, and we're making a rectangle. So throughout these videos, what we're going to do is we're going to condense the size of these rectangles. We're going to look at left-hand sums, we're going to look at right-hand sums, midpoint sums, and trapezoidal sums. So what you notice here is what we have done is these rectangles roughly get this area bounding by the curve from 1 to 7, right? Yeah, there are some points where it goes over, there's some points where it goes below, and that's okay. Okay, because this is just an estimate. What you're going to do is you're going to add up all of the areas of those rectangles. So as I want to find the area of rectangle 1, and the reason we're doing this is because we want to calculate the integral from 1 to 7 of f of x dx. That's how you write that. And so what we're going to do is here on rectangle 1, I know that that is going to be a base because the length of the base is 2. Times the height of the rectangle. And the height of the rectangle is going to be f of 1. So we're going to multiply those. And then now in rectangle 2, I have a base of 2, and I'm going to multiply that by the height. And I can see that that's 8, but I'm just going to write here f of 3. And then now finally in our third rectangle, I'm going to go, I have a base of 2 again, and my height is going to be f of 5. And that's going to find all of our rectangles. So you might be thinking, how am I going to find f of 1? How am I going to find f of 3? How am I going to find f of 5? Because I don't have those exact values. Well, we do have the function that we can actually type in f of 1, we can type in f of 3, we can type in f of 5 and get the exact value. So let's go ahead and do that. Before I do that though, I do have a chance to simplify this. So I'm going to factor out 2 from everything, and I'm going to add up f of 1 plus f of 3 plus f of 5. Kind of simplify the calculations here. And when you find those values rounding to 3 decimal places, 42.667. So 42.667 units, that is going to be an approximation of the area underneath the curve from 1 to 7. So now let's look here at our second and third problems. Notice here that the function has stayed the exact same, okay? We had the exact same function, we're still going from 1 to 7, but in our first problem, we're gonna find it at 1 unit. In our second problem, we're gonna find it with a half a unit. So doing the same thing, you're gonna go 1 unit, make a rectangle. And then at 2, again, this time we're only going 1 unit. Now at 3, going 1 unit, 4, 5. And then over here on this next one, we're gonna go half a unit. All right, so here we have the rectangles drawn so that you are able to actually make these calculations happen. So here in this one on the left, we're going to find the integral from 1 to 7 of f of x dx. And we know we're gonna, since the length of all those bases are 1, we could factor that out. So 1 times, and we're gonna have f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6. And then on the second one, on the one on the right here, we know that as we're going to do this one, again, I'm going to go from 1 to 7 of f of x dx. And since this is an estimate, we're going to find this from 1 to 7, and the base, the length of the base for all those rectangles is 0.5. And we're going to go f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus yada yada yada. You know you're going to have to add them all up, so you're going to add them all up, and that's going to be plus at the end f of 6.5. So you're gonna have to do 3, 3.5, so on and so forth. So what I want you guys to notice, and you might be thinking about this as you're looking at all of these rectangles, as I get closer and closer, as I get the length of that base decreases from 2 to 1 to half a unit, you might be thinking, can I do a quarter of a unit? Because the area that it's going to be going over or under in some of these spots that you might be seeing, it's like right there, and then over on these areas, it starts to shrink as the length of these rectangles get smaller and smaller. And that's the whole point of Riemann sums, and that's how they get us to the idea of definite integrals. So I want you guys to calculate these two values and see if you get the same as I. All right, so those are going to be the two values that we have. And what you might be wondering is, okay, which one is actually closer to the exact area? And hopefully you've concluded that the one with the smaller amount of intervals, or the smaller intervals of the bases, the 0.5 one here on the right, are going to have the more accurate solution. So we started with 42.667, we went to 41.667, but the correct answer is actually closer to 40.917 here. So that's going to conclude this video on left-hand Riemann sums. We still have to cover right hand. We still need to cover trapezoidal and midpoint sums. So stay with those videos. Of course, if you have any questions on how to calculate these Riemann sums, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.